All right, welcome to the 7-6 Improper Integrals lesson, where we are trying to evaluate these things called improper integrals. This is, of course, a BC only topic. It should be good times. Okay, so notice over here on your assignment, you got a handful of problems, sure. Do what you can, but also homework supplement, you've got free response question that you want to give some attention to. So let's take a look at our warm-up here. So the solid formed by revolving about the x-axis, the unbounded region lying between the graph of fx equals 1 over x and the x-axis for x greater than or equal to 1 is called Gabriel's horn. We want to find its volume. Okay, so this is the first time that we've seen, or we're working with an unbounded region. That means it just goes on and on, off to infinity, or maybe it's negative infinity, in this case positive infinity. So we're starting at 1 and we just keep going. So previous to this, we would have started at 1 and said, gone to 3, revolved that around the x-axis and got a volume. This time, it's just supposed to be infinitely big. All right, so if it's infinitely big, is it also going to have an infinite volume? Let's see. Okay, so what I'm doing is I'm going to revolve this thing around the x-axis. All right, so let's do what we have done in the past. Make ourselves a little representative rectangle there. All right, and the width of that rectangle, of course, will be a delta x, as if we're partitioning our interval here from 1 to a whole bunch. Okay, when I spin that rectangle around, it's going to make a disc, not a washer, but just a disc. Maybe I'll draw this over here. All right, so let me draw in. All right, so something like that. I put too much of this here. Now I'll just erase this and then put it in there again. Oh, that's beautiful. All right, now I'm going to put the rectangle in here so you can kind of visualize where that was and color it in as well. There we go. So there's that delta x business. Okay, the other piece of information that we need, of course, is its radius length. So its radius length is this thing. It's this here, which is just basically the function value. It's 1 over x. And remember, we're basing this whole thing on pi r squared h, which is the volume of one of these disks, and we're going to, add up a whole bunch of them. So here's just going to be our approximation first. We would have that the volume is approximately equal to, we'll have our good old summation thingy from I equals 1 to n, and we need a couple of pieces of information. We're going to, again, build it like this. We need a pi in there, and our function is going to be our radius being squared, which we already said was 1 over x sub I will say, squared, and then times the width. So this is delta x. Okay, so this is just an approximation, and in order to find the actual volume of this thing, we need to take the limit as n goes to infinity. All right, so this is going to look sort of like this. This is exactly what we just set up, right? When we take the limit as n approaches infinity, this is supposed to turn into some sort of definite integral, right? And so here's the problem that we haven't had before, is that upper bound there is infinity. And it's supposed to be a number. It's supposed to be like 3 or 4, something like that. And that's a problem, right? So this thing is what we call an improper integral, since one of its limits of integration is obviously infinite. Sometimes it's not obvious, as we'll see here in a little bit. All right, does this mean that we can't solve this thing? No, but what it is going to mean is that we're going to have to turn this thing back into a limit. Now, what I do want you to understand is that AP, if this does come up on a free response question, they're very, very particular about their notation. And if you leave that infinity as one of the bounds of integration and you don't turn it into a limit, definitely an opportunity for you to lose some sort of points. Okay, so talk a little bit about this like Gabriel's horn thingy here. So it's an actual thing. Well, did you pick up on that horn sound right there? So this is what the thing is going to look like whenever we revolve it around the x-axis. And this is actually written into the AP exams frequently asked questions. If Gabriel's horn actually sounds while you're taking your AP exam, everyone automatically earns a 6. Not a 5, but a 6. What actually is this Gabriel's horn thing? Like, what is it actually referring to? So if you don't know, it refers to this archangel Gabriel from the Old Testament, who's supposed to blow this horn to call the faithful home to heaven, I guess, on Judgment Day. So for more information about that, just check out movies like, I don't know, 28 Days Later, something like that. And you see the picture over here. Little shirt I made would be fantastic to wear. I mean, you'd wear that out to, I don't know, study sessions at Panera or Whole Foods, wouldn't you? I think that I would too. Okay. So in the next video, we're going to take a look at trying to do some of these little problems. But like first, let me go back here and like we called this thing an improper integral, right? And the reason why we're making a big deal about it having a little infinity there is because it breaks the definition of an actual definite integral, which was right here. So notice that it says if f is defined on a closed interval. Closed interval, that's not something that we had. It started at 1 and went to infinity. That's not a closed interval. So there's the first thing that it violates. Okay, let's say that we got around that. The second thing is the fundamental theorem of calculus. So the fundamental theorem of calculus says that it has to be a continuous function. And we're going to see that we're going to have some functions that have a vertical asymptote. And this is going to turn it into an improper integral. And since it's not a continuous function, we can't actually apply the fundamental theorem of calculus. And again, this goes back to if this thing appears on a free response question where they're looking for notation, be very, very careful. Don't be so lazy to just leave that little infinity sign in there. If it's improper, you're going to turn it into a limit, as we're about to see.